Hello everyone. This is a video lecture for Calculus 1, section 2.7, derivatives and rates. So, what is a derivative? I'm going to tell you what is not a derivative. Ha ha ha. Kind of just joking around. Let me show you what's going on with this derivatives and rate stuff. So, they're going to want to talk about tangent lines very often. It's all kind of revolves around like this. And they're going to compare it to a secant line. So what I want to do is just show a graph of something like I've probably shown before. I'm trying to remember if I have with you guys. So I have a point, say, right here, and then I have another point right there. And a secant line is a line that connects two points. This is called a secant line. Well, a tangent line is with only one point. And so how do I get that? Well, let me use some more colors to kind of keep going. I'm going to use magenta. So let's say that right here, let's say. Notice that these 2 points now are closer to one another. It's still secant. It's still a secant line. But we're getting closer. Eventually, it'll come all together to be right here. And that finally is my tangent line. Okay. The goal in doing all this is that I'm trying to take this second point here, and I'm trying to move it closer and closer to the original. Okay, I'm trying to make it closer and closer to the original. I'm trying to make the distance between those 2 points, right here, I guess, and right there, and right here. I'm trying to make this distance here, which we would call delta x, I'm wanting it to go to 0. I want this distance here to be shrunk to a single point, okay? So I'm wanting my delta x going to 0. This is all going to be very important when we actually do real derivatives eventually. For right now, I'm just kind of showing you around. Okay, I think right now that's good enough. I just wanted to talk about it. Let's do some problems. So 27015, I have a very strange graph. It does this, and then this, and then here, and then there, and then this. And they say, what is the velocity graph? What is the velocity graph? And I believe it's multiple choice. I'm not going to keep a box there. I'm just going to draw it here. So how do we make this thing happen? Well, velocity is the same as slope, which is the same as tangent, which is the same as derivative, which is the same as the rate. They are all the same thing. What I'm wanting to do is find the slope. And so slope is what we're really looking for. What I did here on this graph is I calculated what that slope would be. And for example, let's say this is a 1 and this is actually a 4. So then my slope is going to be a 4. Okay? The slope here is 0 because it's flat. The slope here is a -3. The slope here is 0 again, and the slope here is a 1. I use the grid. It's all on a grid that I can kind of see. Oh, yeah, that's the slope. Rise over run, that kind of thing. And so my answers, my heights, are going to be these numbers here. So now I got 1, 2, 3, 4. I have a height here, and I'm going to put circles, not solids. And then I got 0. And then I got -3. So 1, 2, -3. And then I got 0 again. And then I have a 1, which would be a little bit higher. That's it. Now, it's not perfect, but it's supposed to line up with where these changes are going to be where the changes are here, x values and stuff. So this is your answer. It's weird. I know. So I'm just reminding you, this is how I got all that, okay? I just looked at these slopes, and those are my new y values. Next question. 708. And so they say this is a ball in the air, and it's going at 38 feet per second initially. And they give me an s of t, which is kind of like a position function, of 38t minus 16t squared. So it says find the velocity at t equals 1. So what's really going on is that we have a ball and it's thrown up in the air and then it comes back down. But it doesn't look like this. It's not like I'm standing here and I'm trying to throw the ball at somebody. In reality, what's going on is that it's going straight up and then it's coming straight back down. But you know how that arc is. It's better represented this way as time. Okay, so this is a time and this is a height. If this was like, this is x and a height, I guess you could say. So it's actually not moving x-wise. I don't really care about that part. I just say it's going up and coming back down, straight up and down. But the motion is going to be this parabola. You see that parabola action right there? Okay, so what is this velocity formula that we need? It says find the velocity. What's the velocity formula? Well, here we go. It's the limit as x goes to a of f of x minus f of a divided by x minus a. Now, I don't like the letter a at all. I do not like it, but I'm going to be using it because that's what the book is trying to push on you, and, well, I guess eventually I have to succumb to peer pressure. So, the limit as t goes to 1 of, and see, I'm using x instead of t instead of x, that kind of thing, of s of t minus s of 1, and that 1 comes from right here. It's a fixed number, divided by x minus 1. And so I have my function, which would be my 38t minus 16t squared, minus s of 1. So now I'm just going to plug a 1 in, so 38 times 1 minus 16 times 1 squared, all divided by. I don't know why I put an x. It's supposed to be a t here. T minus 1. And so what I want to do is combine like terms in the top and all that kind of stuff. And what you eventually get, not an infinity, it's a 1. What you eventually get is negative 16t squared plus 38t and then minus 22. Okay, so all this stuff here came to a negative 22 kind of thing. And then divided by t minus 1. And I need to go and plug in a t equals 1. And when you do, you basically get 0 over 0. And you can't do that yet. Can't do that yet. But we will do that eventually. Until that time, what do? Well, I'm going to suppose that the top is going to cancel with the bottom. But I don't know what that term is going to be in order for that to happen. See, so this is the goal. And then I could just have that or whatever else is left over. To do that, I'm going to take this and use synthetic division with a 1 on it. Now, why that? Why? What's going on here? So I'm wanting to factor this, and I know that one of my answers is going to be a 1. At least I'm assuming that. And so this is t equals 1, or again, t minus 1 is a factor, either way. And I'm doing the synthetic division just because it's quicker, honestly. You could do all kind of different methods. Quadratic formula is totally fine. But yeah, good luck with that. So I got negative 16, and then I got a 22. 22 and 22 cancels. So that's good. I assumed that it would work, and it did. And what I'm going to get out of it is a 16t plus 22. So what's really going on here, let me just kind of zoom out. And see, I got my limit is now going to be the 16t plus 22 times t minus 1 all divided by t minus 1. And so what happens is I cancel those guys, and then I actually plug in the 1. I apply that limit, and my answer should then be just a plain old 6. And that's your answer. Could I have gotten this 6 answer quicker? And the answer is yes. But it's not right now, not in Chapter 2. I would say that's probably the best way to do it right now. When we get to Chapter 3 and we're actually doing real derivatives, then we'll do that. Okay. So it's 27028. So it says find the equation of a tangent line at x equals 5 given that we have y equals to g of x, that's kind of weird. I got g of 5 is equal to negative 4. And then they got g with a little thing up there, a little, I don't know, quote mark something, an apostrophe. 5 equals 2. And they say, all right, figure it out. What's your tangent line equation? Like an actual equation. Okay. So I'm going to just go ahead and clarify some stuff for you. This thing here is useless, but what we have here is a point. This is a point, and this is an x, and that's a y. And so I've actually got 5 comma negative 4 as an xy point, okay? What this is here is a slope, and we don't call that apostrophe. You call this g prime, g prime, g prime. And it's a slope. So my slope, I guess you could say, a little m, is equal to 2. So g prime, that's how you would, but it just says slope. Well, my tangent line equation, a line equation, is y minus y1 is equal to m times x minus x1. And so I'm going to just plug all those things in. So y minus a negative 4, I got a 2 for my slope, and then I got a 5 for my x. 2 negatives make a positive. Distribute your 2, move the 4 over, and I should get a negative 14. Yep. That's your answer. That's what you put in the box, and you're done. That's it. You have to type the full equation. You have to type the y equals for this to be correct. That's it. So what we're going to be seeing is this g prime stuff. What this indicates is a derivative. And a derivative is a slope. And a derivative tells you what's going on with a tangent line. All of this is all put together. Your derivative is also a rate of change. Okay, so let's do this next problem here. I have capital G. I know my capital G's look weird. I've been told they look weird. Capital G of x is equal to 5x squared minus x cubed. And they say find the tangent lines at 318 and at 416. Now, what I'm going to do is basically just the first one, but once you get the first one, the second one is actually much easier. Like I'll be doing most of the problem, obviously, still. Okay, so it says find the tangent line, and the first question, I guess your part A, is saying find g prime of A. Again, that's g prime, and they're wanting to find the derivative. So I have to find the derivative of this thing, and then I plug it in. One thing to note, big star here, notice that we need to use A and not X. Man, that will be annoying to you on quizzes and exams. If that happens to you on a quiz or an exam, you let me know so that I can fix it and give you full credit, because this is something that I would get wrong myself, because I'm just so used to typing an X, of course. So just remember to use an A whenever we have to. And that's super annoying to me because I don't like using A. All right, so we need a formula for the derivative. This is the formula for the derivative. And that's what we're going to be finding here. You're actually doing calculus now. G prime of A is equal to, here we go, the limit as h goes to 0, so that's a little h goes to 0, of g of A plus h minus g of A all divided by h. That's your formula. Okay, so that's the thing that you're going to have to start memorizing. Derivatives of whatever. Now, the h is something that's actually classic, I guess. We're going to be using the h for sure. But the a is just ridiculous. So, I mean, we're going to use x in this class. We're going to solve for x. We're going to use x. I don't know why. They must have an a. Whatever. That's fine. So we're going to do that, I guess. But the h is okay. That's actually part of the formula, and you should be using an h. What is h? H is actually equal to delta x. And if you remember from my small discussion way up above, right here, I'm wanting my delta x to go to 0. I'm wanting to make my secant line and turn it into a tangent line. Okay? That's cool. And so in this case, I'm saying h is equal to delta x. And you could, in other formulas, replace this with delta x, and then you definitely have a formula for your derivative. Okay? Again, h is still classic. Another thing, this formula actually comes from college algebra. If you've been through 1414 college algebra with us, there was a couple questions about this. And it's called the difference quotient. The difference quotient. Now, you probably had about 2 or 3 problems on this, and then you were done. So I don't expect you to remember this, but in a way you have seen it. So just keep that in mind as well. Okay, so now that we talked about it enough, let's actually do it. What I'm having to do to make this problem work is I need to take my formula and I'm going to plug it in directly. But then I need to take my formula and I'm going to plug it in with a plus h. So everywhere you see an x, it's going to be an a plus h. An a plus h. And it's going to be really big. So here we go. So I'm going to say equals the limit. That's illegible. As h goes to 0 of, and here we go. Here's my formula. But now, instead of x, I'm going to do a plus h. And that was, again, a squared and then a cubed. An a plus h and then a cubed. So that thing minus, and now this thing here, which is just the original. Now it's the original with an a, and then all divided by h. Go. Of course, my first inclination is to just plug in a 0. But what you're going to end up with is a 0 over 0, and that doesn't work because we've already talked about in the previous sections about that. So what we need to do is simplify, and this is certainly something that I'm going to tell you to do. I know there's always tricks, I know that, but here in 2.7 on question number 32 or whatever, this is what you need to do. So I have a square, and so that's going to be 2 of these terms. And then I have a cube, which is 3 of those terms. And then minus, I'm going to distribute the minus sign here. I got a 5a squared plus 2 negatives make a positive, a cubed, all over h. Okay. I'm still not to the next step that I have here. Okay, cool, cool. Well, what are you going to do? You're going to FOIL these things out. You're going to FOIL them. And what I'm going to do is skip ahead. So, blah, 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 and basically, I get... I get 5a squared plus 10ah plus 5h squared minus a cubed minus 3a squared h minus 3a h squared minus h cubed. You got more room, don't you? Minus 5a squared plus a cubed. All divided by h. Now what I did is I foiled like twice. I distributed the minus sign into this stuff here. And there we go. A lot of stuff. But now that it's written out, I can cancel things that look similar. Okay, that was at least a little bit better. So 10ah plus 5h squared minus 3a squared h minus 3ah squared minus h cubed divided by h. And they all have an h. And so what you're going to do is cancel a 1h from everything in the top and this h in the bottom. So cancel this guy here, one of them, cancel one of them, and then this guy's going to turn into a square. 10a plus 5h minus 3a squared minus 3ah minus h squared. And that's it. No divide by h anymore. Now I can actually plug in a 0. Plug in a 0 into your h's. And what happens is that they simply just go away, leaving behind a 10a minus 3a squared. That is your final answer for g prime of a. That's g prime of a. That's your derivative. That's your derivative. That is your slope, just like in the last problem. Remember that they were asking about the tangent line? I mean, what were we doing? Yeah, find the equation of the tangent line. So we got part A, but part B we still got to do. I'm going to take this point 318 and show you how to use it now. So my point here is 318. And again, this is like x1, y1 kind of stuff. But this A is likewise an x. And so I'm going to plug this 3 in right here to get my slope. So my slope would then be 10 times the 3 minus 3 times 3 squared. That's 30 minus, 27 makes a 3. So this is important to us. And so now what I do is I simply do y minus y1 is equal to m times x minus x1. And so y minus the 18 is equal to 3 times x minus 3. Distribute. Move this to the other side. Y is equal to 3x plus 9. There's your full answer. Remember to... Oh, actually, hold on. Apparently, you only typed this in the box. I don't know. That's what I have boxed in. It seems that WebAssign's format keeps changing on us, so sorry. And then what you need to do is all this chunk you're going to repeat for the other point, 4, 16. Okay, so that's going to be your next thing. I'm not going to do it, but you get the idea is that you just plug it back in, and you get your slope, and you're done. And then there's one last part. They're talking about a graph, and it looks something kind of like this here. There you go. Not perfect. I'm just kind of showing you what it kind of looks like. Click that one. Cool. We've got 2 problems left, and one's pretty easy. So 27055. I have a t and a c of t. And so we got 1.0, 1.5, 2.0, 2.5, 3.0. I'm getting bored. So then I got 33, 26, 2.2, and then I got a 14, and then I got a 0.9. All right, cool. Okay, so it says find the average change, and they give you a, for part A, they give you a, I guess like a domain, an interval that they're wanting to look at. So 1.0 to 2.0. And change is, guess what? That's slope. Yep. So my slope is y2 minus y1 over x2 minus x1. And so my y values would be a 0.2 minus the 0.33 divided by 2.0 minus 1.0. I mean, I'm just grabbing those values. Plugging it all in, I got a negative 0.13, and there you go. After that, my part B and part C and all that stuff is just going to repeat it. No problem. Keep moving. Next, last problem. So, f prime of a, that's f prime. Again, that's a derivative, okay? Now, I do not like using these a's. You will not continue to use the a. The a is only right now. We will use x later. It will be okay. So find this derivative if my original f of x is equal to 1 over the square root of x plus 6. Now, I don't do every single problem on your homework. I don't. There's definitely some problems out there that I didn't do. I probably did not do a lot of easier ones. I don't know. Maybe there is a harder one that I didn't do. I'm not really sure. But this one here is a tougher one. And suppose here that I were to give you the Chad method to be able to figure this thing out quickly. Like, as in, the Chad method is just go to chapter 3 and actually just do some calculus. If that was the case, this one here would be a little bit more difficult. The last one would have been easier. Not this guy here, but the one before it. We could have figured this answer out pretty easily using just a very small chapter 3 concept, okay? I'm not going to do that right now. I'm trying to be a good teacher. But this one here, yes, it's kind of like that, but it's also a little harder. So I'm not going to do that at all, just like I didn't do with the last one. But I feel like sometimes they put these harder ones in here so that they know we can't cheat, that we have to do it the long way. And here we go. Let's do it the long way now. Okay, this is it. And then you're done with the section, so we're almost there. So f prime is equal to the limit as h goes to 0 of f of a plus h minus f of a all divided by h. Again, they will want you to have a's in your answer. Okay. And hopefully that'll go away soon. So I'm going to take this and I'm going to plug it in wherever there's an x. And so it's going to be pretty big. So here we go. I've got 1 over the square root of a plus h minus 1 over the square root. Oh, whoa. I'm still not done. Back up. A plus h. Here, let's even make it bigger because it's not, yeah, we need some bigger. So this is a plus h plus 6. Notice all of that was my x. And then plus 6. Okay? Okay. So all of this minus, and now the original, just a instead of x, a minus or a plus 6, and then all divided by h. Whew. Yeah. What do we do? Exactly. What I say here is find a common denominator. Now, I will skip steps. I will skip steps because that's just, I'm going to have to. So that means that I'm going to multiply this side by this guy right here, top and bottom. And this one right here, multiply it, top and bottom. And then you apply the minus sign to the numerators. And we get a plus 6 minus a plus h plus 6, all divided by square root of a plus 6, now times, common denominator, of a plus h plus 6. All of this divided by h. That's your big division. My goodness, how is that any better? Well, this h can actually come up right here. That's h over 1 technically, and so you would flip it into the numerator. So let me just redraw that. Is your hand hurting? Is this just too much to keep drawing? Totally understand. And all this in the denominator is being multiplied. That will be important here in just a few minutes. Okay, big division. Whew, now what? Yes, exactly. What you're going to have to do is multiply by the conjugate of the numerator. So, if you didn't have enough to write, now you need more. Yeah, exactly. So, you're multiplying by the conjugate of the numerator times both the numerator and the denominator. So, notice conjugate is the same thing, just with a plus sign. Now, why am I doing that? Well, the reasoning behind it is that you're going to cancel stuff. So when you FOIL this thing out, you got 2 square roots make like a single, like an original, like a 1 power. So I'm just going to say a plus 6. When you got this square root here times that one, it's huge. But then this one here is the same thing. Positive and negative are going to cancel. So I'm not going to even draw it. And then the last step is this guy times this guy. Again, the same square roots, but they should cancel. There is a minus sign still in the front. So we got this guy, and then we got my inside, but now with a minus sign there. Okay, so that was my numerator. In the denominator, it's just a mess. It's just a mess. And I recommend leaving it alone. Do not touch it. I know you want to simplify. Okay, that was a lie. I know you don't want to simplify, but leave it alone. Okay. Wow, what's going on? Okay. Well, if you look up here, you can apply this negative to each one of these here, and that's a negative A and a positive A, and they're going to cancel. And then we got a 6 and a negative 6, and they're going to cancel, leaving you with just a negative H. Whew. This is one heck of a problem. Doing it the chapter 3 method is much easier than this, okay? But it does require a lot more concepts and talk about it. The H's are going to cancel, leaving a 1. That's going to be a negative 1 in the top now. And now what you do is you actually apply this 0, H equals 0 business to this guy and this guy. And so what you're going to actually have is A plus 6 and A plus 6. And these are the same thing. I don't have a limit anymore. I'm literally applying it. So what I have now is A plus 6 and A plus 6 and the 2 square roots combined to make a regular 1 power A plus 6. So both of these turned into this guy. Over here on this side, we got an A plus 6 plus an A plus 6. There's 2 of those square roots. So 2, so this is all multiplied. 2, and then we have that square root. We had 1 here, and we got 1 there, and both of these guys make this thing right there, okay? And that is your answer. That's actually where I stopped. And again, this is not a B, this is a 6. That is an A, not a 9. There it is. I guess you can make it look pretty if you want. So 1/2 times 1 over, and you can combine these together to make that into an A plus 6 all to the 3/2. Either way, not required. Okay, we did it. We're done with that section. Whew. Thank you very much. Have a great